Hello everyone. Am I audible?
Yes, ma'am.
Okay, so we will wait for 5 more minutes. We'll see if others join. Okay, so hi, all of you are in your MSc now. Okay, so hi everyone. I am Riturani Mandal. I am a PhD student in IISc Bangalore. So I will be taking this course of yours. It will be in every Monday, 7 to 8 p.m. So can you guys just give your brief introduction one by one? Hello.
My name is Ashish Kanpal, and I have done my masters from Central University of Punjab, Bathinda, in specialization in computational and theoretical chemistry. And currently, I am aspiring for the GATE.
Okay. Deepika.
Good evening, ma'am.
Good evening.
My name is Deepika, and I have currently completed my BSc Non-Medical from Punjabi University, and I want to go for GATE 2023.
Okay, so you have done your BSc now.
Yes, ma'am.
Okay. Gautam.
Hello, ma'am. This is Gautam. I did my master's in VIT Vellore. Currently, I'm positioned as a project staff in VIT Vellore. I'm aspiring to clear GATE by 2023. So I joined the class. Yeah.
Okay. Shikha.
Hello, ma'am. Good evening, ma'am.
Yeah.
Ma'am, my name is Shikha, and I have passed MSc in chemistry from Guru Nanak Dev University, Amritsar, and I am aspiring for GATE 2023.
Okay. Shiva.
Good evening, ma'am. I'm Shivakritika. I completed my MSc in Lekatulapo College under MS University, Tirunelveli in Tamil Nadu.
Okay. Archana. Okay, Archana left the meeting. Nikita. You are not audible, Nikita. Mm. Okay, Nikita, you are not audible. We'll come back to you afterwards. Bhavesh. Hello, Bhavesh. Are you there? Okay, Tuhin.
Yes, my name is Tuhin Mandal. I completed my MSc in organic chemistry on 2018. Now, currently, I am a project associate in CSR Simphat Dhanbad.
Okay. So I will be teaching in this course, like I will be solving previous year questions, and I will mainly look on the inorganic chemistry part. Okay, I think you guys know that. So all of you guys want to like join for PhD, or you are like after giving it, you want to go for a job?
Actually,
Ma'am,
our
job.
Okay.
current motto is only just qualified the GATE exam. After that, we think. Uh, Actually, what is better for us? A job, a research.
Okay. Okay then. I and like uh, what are your guys' expectations from this course? Like what you feel, what do you guys expect from this? It will be better for us. Like if you guys can share your views, then we may come up with something new.
Ma'am,
Yes,
please try to solve more and more questions
Yeah.
like PYQs and interesting more and more questions we want to practice.
Okay, so have you guys like seen previous year question papers and all? Like, are you aware about what type of questions come and those things, right?
Ma'am, I think please go with brief introduction, like you are saying that for inorganic chemistry. Please brief introduction and start for question practice.
Okay, so in basically in inorganic chemistry, like that you will get in your syllabus that mostly coordination chemistry is a thing. From there you will get questions. From main group chemistry you will get questions. Then organometallic reactions. Actually, as I don't know whether you guys know that or not, but from 2021, actually after BSc also people can give, they can appear for GATE. So earlier it was just for like only people who were in their MS and after doing MSc, then only they were giving GATE. But now because BSc students can also give appear for that exam, so somewhat the question like level of questions are now different from what it used to be before. Okay, so you will mostly get basic type of questions mainly. So today let's we we are planning to solve a like today we will start with solving a few questions. So first question which I want to show you guys is just wait. So we will be starting with 2021 question paper. Okay. So here our plan is that every like in every session we will take like 3 or 4 questions, whatever the time permits. We will see that. And for every question, first we will discuss a little bit about that topic, and then we will go move on to solving the question. Okay. So I am sharing my screen. I said we will. Is my screen visible?
Yes, ma'am.
Okay.
Yes.
So as I told you guys, in GATE exam there will be like first general aptitude part. So in this general, this is 2021 GATE chemistry paper. So first you can see there will be 5 questions, which will be 1 marks each. These questions will be from general aptitude part, and then there will be multiple choice questions from question number 6 to 10. This also falls in the category of this general aptitude only. So in every question there will be -1/3 of the marking. Like when we are having 1 marks question in those questions, you will get -1/3 for every wrong answer and +1 for every correct answer. And from question number 6 to 10, +2 for every correct answer and -2/3 for every wrong answer. After these 10 questions only, your chemistry section will come. Okay. So here from question number 1 to 14, you will get multiple choice questions which will carry 1 mark each, and for each wrong answer it will be -1/3 marks. We also have after that MSQ type of questions. Okay, so question number 15 to 18 are multiple select question in which more than one option can be correct, and you have to give like you have to choose all the correct options or else you won't get a mark. But there is no negative marking for these questions. And then you have NAT type questions as well. Okay, so this question number 19 to 25, you can see that for question number 19 to 25, you will have this NAT type questions. They will also carry 1 mark each and no negative marks for that. And then there will be 2 markers question and all those things. Okay. So today, as we said, we will start with inorganic chemistry. There are total of 55 questions from chemistry section. Okay. So today we are planning to solve.
All
Yes.
total, yeah, only inorganic portion.
Wait, someone is. I will be looking after this inorganic portion. So you guys can see in our that gate portal, it will be given like for every other topic, for each of the topic, different meeting links will be given. Okay. So I will be specializing in this topic, but you will like in other link in other by going to the other links, you guys can join the other classes as well. So there you will get this video solutions for your organic as well as physical chemistry part. Also in our gate portal, I don't know if you guys are aware of that. Do you know that NPTEL official portal?
Yes.
You guys know, right? So this is the portal. If you go in this gate syllabus mapping wala portion, here you can find there is chemistry. So if you go in chemistry, here there are different subjects which are which are in the syllabus for gate exam. So for different things you can get the videos. Okay, like for the subject organometallics, if you want to know about the topic 18 electron rule, you will get different lectures which are available for that. These lectures have been given by professors from different IITs and IISc Bangalore and all. Okay. So this is one way. This is for your gate syllabus. Everything, most of the thing you will find here. And for video solutions, you have to go here. We are like here you can see. Now only 2022 questions are available here. So we are working on it and we will be soon updating the video solutions for the next years as well. Okay, for 2021. So we are right now working on 2021. So in this way, you guys can also look on the video sessions and all whatever we have. So yeah, your question was that will I be looking on that inorganic portion only? So yeah, I will be teaching you people that only. So we will start with this question. Question number 9. Which one of the following is a non-heme protein? Okay. So first of all, I will be showing you guys this video which I have recorded for you from earlier only. You guys can watch that. Wait. Okay, so if you have any doubt or anywhere, just watch the video and note down your doubts. You guys can ask me once it is finished. Okay. Hello.
Sure,
Okay,
ma'am.
Okay.
ma'am.
Yeah.
Yes, ma'am.
So this is visible, right? The screen is visible. Video
Yes.
gate questions.
Yeah.
Okay. Okay. So you see that. If you have any problem, let me know after this finishes. Hello everyone. Today we will be solving this GATE 2021 chemistry question. The You guys can hear the voice as well, right?
Yes, ma'am.
Okay. Question
Not
is,
actually
which one
loud.
of the following is a non-heme protein? The options given are hemoglobin, hemocyanin, myoglobin, and cytochrome P450. For solving this question, first of all, we should know what are heme proteins. So, what are heme proteins? Heme is an iron holding porphyrin ring. This is a porphyrin ring. So, a porphyrin ring is made up of 4 pyrrole rings, and in different proteins, there are different substituents on this porphyrin ring, and an iron center is coordinated to this nitrogens of the porphyrin ring. So, any protein which do not consist of porphyrin ring or iron center are known as non-heme proteins. The given options in this question are myoglobin, hemoglobin, hemocyanin, and cytochrome P450. So this is the structure of myoglobin. We can see that in myoglobin an iron 2 center is present. So this is the structure of deoxymyoglobin. Here iron is present in +2 oxidation state, and this is coordinated to these 4 nitrogens from this porphyrin ring. This porphyrin ring have different substituents. We can see that here. Hemoglobin is an polymer made up of this myoglobin units only. So hemoglobin has 2 alpha chains. Guys, just wait for 1 minute. I think someone is trying to join the class. Hello, sir.
Hey, hi. Oh, sorry, just continue. I just
Okay. Actually, I was showing a video, and so I just paused it and
no problem. I just thought I'll
Okay.
say hello and see if everything is going. This is the first class we are doing today, right?
Yes, sir.
Yeah.
Okay,
Okay, yes,
sir.
and thanks.
Okay,
This
sir. I
is
will
this is
continue.
which subject you're doing?
So chemistry, I am specializing in inorganic chemistry.
Okay, perfect. No, so I'll just say hello to the kids. So hey everybody, my name is Ramkrishna. I'm a faculty at at IIT Madras Electrical Department. I also coordinate NPTEL. So please drop in your feedback of what you think of these sessions and how you would want to improve and so on, and we will be able to help you out. Okay. Thanks, Ritu. And we have wonderful people like Ritu, exceptionally talented, wonderful research scholars who will help you through the process. So please feel free to write to us. Okay. Yeah, I'm back to you.
So if you get a
Thank you,
question
sir.
with instead of 16 gram, if you are using a 64 gram, or if you are using 64 grams impulse to transmit, could you please tell me what will be the
What was your question? Hello? Okay, so I am continuing the video, okay? Sorry for the interruption. Hello everyone. Today we will be solving a porphyrin. Options in this question are myoglobin, hemoglobin, hemocyanin, and cytochrome P450. So this is the structure of myoglobin. We can see that in myoglobin an iron 2 center is present. So this is the structure of deoxymyoglobin. Here iron is present in +2 oxidation state, and this is coordinated to these 4 nitrogens from this porphyrin ring. This porphyrin ring have different substituents. We can see that here. Hemoglobin is an polymer made up of this myoglobin units only. So hemoglobin has 2 alpha chains and 2 beta chains. Each of this alpha and beta chain consists of this myoglobin unit, which have iron in +2 oxidation state and a porphyrin ring. Now moving on to hemocyanin. In hemocyanin, the metal present is copper. This copper is present in +1 oxidation state in deoxyhemocyanin, and each of the copper center is attached to 3 histidine residues from the protein chain. This is the structure of cytochrome P450. Here the metal center present is iron in +3 oxidation state, and here also this iron is coordinated to 4 nitrogen from porphyrin ring. So from the structure of these 4 metalloenzymes, we can see that only hemocyanin is the one which don't have iron and no porphyrin ring. So this among the given options is a non-heme protein. So therefore in this question, which one of the following is a non-heme protein? The correct answer will be option number B, which is hemocyanin. For getting more insight onto this topic, please refer to the following videos: Bioinorganic Chemistry by Professor S.P. Rath from Department of Chemistry, IIT Kanpur. In lecture number 15 and 16, he has discussed about hemoglobin, myoglobin, and hemocyanin. And in the lecture from Debashish Rai on bioinorganic chemistry from Department of Chemistry, IIT Kharagpur, in lecture number 33, you will know about electron transfer proteins like cytochrome P450. The link for the above videos is given. Please go ahead and watch the video. Thank you. Okay, so as you guys would have understood that this question falls in bioinorganic chemistry. So this question was from bioinorganic chemistry. Now, any doubts? You guys have any doubts?
No, ma'am.
It's clear, right, everyone? Yeah, I'll call out names.
Yes, ma'am. It's clear.
Clear, right? So you people can like write these links and all. It will be helpful. Like, see, as I said that in this course we will be solving the like we will be solving the solutions, like solving the questions. So therefore it won't be able to know too much details of the topic. Maybe sometimes you can feel that, so you guys are free to ask me. If that is within the scope of this lecture, we will definitely discuss that, or else I can always suggest you guys to look into some lecture which is given. I said like in that GATE syllabus there are various videos from various universities. They have given like properly every topic is discussed and all in detail, so I can always suggest you guys. So I hope this was clear. Now you guys I think you people knew what is a heme protein and all, right? Okay, so shall we move on to the next question, or there are any doubts in this?
Okay, ma'am.
Okay, we will move on to the next question, right? Okay. Okay. So the next question which we will be discussing is question number 13. So for this also I am playing a video. If any questions, please let me know. Today we will be solving this question which came in GATE 2021. The question is the rate of substitution reaction of COCN5 Cl whole 3 minus with OH minus to give COCN5 OH whole 3 minus depends on the concentration of option number A COCN5 Cl whole 3 minus and OH minus. Option number B depends on the concentration of COCN5 Cl whole 3 minus only. Option number C is directly proportional to the concentration of OH minus only, and option number D is inversely proportional to the concentration of OH minus. So in this question the given complex is COCN whole 5 Cl 3 minus, OH minus is attacking, and we are getting this as the product. So this is an octahedral complex with 5 Cl ligands and 1 Cl ligand, and the resulting complex is also having octahedral geometry with 5 Cl ligands and 1 OH. So this is a ligand substitution type of reaction. We can see that this compound is Ml5 type of complex. OH minus is the incoming ligand, and we are getting this ligand substituted product Ml5Y. Since here the incoming ligand is OH minus, this type of reactions are known as base hydrolysis reaction. So, base hydrolysis reaction can take place in two ways. One, via the associative mechanism. Also, it is analogous to SN1 CB mechanism of organic chemistry. So, in this mechanism, what happens is that the complex will first react with this incoming ligand, and this intermediate will form with coordination number 7. Here the coordination number was 6, and after that the existing ligand will leave and it will give the substituted product. This will again have coordination number of 6. So in this case the reaction intermediate has higher coordination number than reactants or products. In case of hydrolysis reactions, in case of this base hydrolysis reactions, what happens is that if this complex consists of any acidic proton, then the reaction goes by this associative mechanism. And the rate will be dependent on both this complex Ml5X and the incoming ligand Y. But here we can see that in our given complex, it is COCN whole 5 Cl whole 3 minus. So in this complex, there is no acidic proton present. So this type of mechanism can't take place in this reaction. The other mechanism for getting this base hydrolyzed product is the dissociative mechanism, which is analogous to SN1 mechanism. In this case, what happens is that from this 6 coordinated complex, First, it will dissociate into Ml5 with coordination number of 5, and the ligand X will come out, and after that Y will attack this Ml5 and the substituted product will form. So in this case, this step, the first step of dissociation, is the slowest step, and hence this is the rate determining step. Therefore, the rate is dependent on the concentration of this complex Ml5X only. Since in the given question, in this complex, there is no acidic proton available, this reaction will go via SN1 mechanism, and hence this will be our rate determining step, and the rate will depend on the concentration of COCN whole 5 Cl whole 3 minus, and it will be independent of the concentration of OH minus. So going back to the question, here first we will write the rate law. So we found that our rate is equal to K1 CO Cn whole 5 Cl whole 3 minus. So the first option is depends on the concentration of both the complex and OH minus. No, there is no dependency on this incoming ligand OH minus, so this is the wrong answer. Depends on concentration of COCN5Cl whole 3 minus only. Yes, this is correct. Is directly proportional to concentration of OH minus. No, there is no dependency on OH minus. Is inversely proportional to concentration of OH minus. This statement is also false. Therefore, among the given options, option number B is the correct answer, which is the rate of substitution will depend on COCN5Cl whole 3 minus only for this reaction. For getting more insight, refer to this NPTEL video on coordination chemistry by Debashish Ray. In lecture number 37, he has discussed about various reaction mechanisms. The link to the above video is given. Please go ahead and watch. Thank you. Hello.
Is the video you played available in the website?
No, it is still not available, but it will be soon available in the website. But you can ask me if you have any doubt. Yeah, it was, your voice is breaking. Can you just repeat?
If uh, uh, if uh, if we record this video, can you share the link?
Yeah, as I told you guys earlier only that about this gate portal. Okay, so in this gate portal, it will be soon uploaded. So we have to actually go through a full process, so it takes a little bit time, but it will be soon available in that portal. You have to open this gate.nptel.ac.in and then go to video solutions. Then you have to choose here. Now, as I said, only for 2022 it's available, but we will be soon uploading this for uploading these solutions for 2021 as well. We are working on that.
Okay, thank you.
Yeah. So any question?
Ma'am, definition of base hydrolysis reaction and one general example.
Okay. So here, what happens is, in this question, what is, we were having this. Here the option given was this, right? So in base hydrolysis, what happens is that the incoming ligand, first of all, I told about ligand substitution reaction. Okay, so this base hydrolysis, this falls under ligand substitution reaction. So what happens in ligand substitution reaction is, you will have one complex which will be of, say, for octahedral complex, it will be an ML5X type of complex, and then one ligand will attack, and then what will happen is ML5Y will form. Okay, so in case of base hydrolysis, just this incoming ligand is OH minus. So that is the definition of base hydrolysis reaction. Whatever ligand is present here, as in this case, we can see that the Cl was the ligand, Cl is X here, and when we are getting the product, our product is this, right? So we can see that Cl is getting replaced by OH. So when your one ligand will get replaced by OH, then that type of reactions are known as base hydrolysis reactions. Clear?
Okay, ma'am. Thank you.
Yeah, and the example is that in this case, what you should know, because here what I told is this reaction can go in two ways, right? One is associative and the other one is dissociative.
Dissociative.
Yeah. So when this associative and when this dissociative mechanism will take place, that you should be careful, since in this case there was no proton available in this given complex. That's why this reaction went by dissociative mechanism. But let's say the question has CONH3 in it. Okay, let's say it is CONH3 whole 5Cl. Okay, so in this case what will happen is that this reaction will go via associative mechanism, because this NH3 we have this NH3 group, right? So this is an acidic proton. So therefore in this question, if the question was with CONH3 whole 5Cl instead of COCN whole 5Cl, the answer would have been associative mechanism, and in that case our rate of this reaction will depend on both the concentration of CONH3 whole 5Cl as well as on the concentration of the incoming ligand, that is OH. So in this case, the rate of it is a second order reaction. Okay. So in this type of questions, you should be careful on checking, first of all, if there is any acidic proton is present or not. That was the main thing in this question. Is this clear?
Yes, ma'am. Okay.
Is anybody else having any question? Hello?
No, ma'am.
Okay, so I can see a few more people also joined while I was solving this question. So did you guys understood? Like who all are the people who joined after some time? Anand Kumar, I think you joined in between. Hello? Hello? You are not audible? Yeah,
Hello,
now.
ma'am.
Yeah, now I can hear you.
Yes, ma'am. I joined the last minute of the session.
Okay, so Where are you from?
Ma'am, I'm from Tamil Nadu, Coimbatore.
Okay, you completed your masters or?
Yes, ma'am, I completed my master degree.
Okay. From which college?
Ma'am, I'm completed in NGM near Pollachi. Now I am working in lab assistant, ma'am. So I plan for GATE.
Okay, so for you, this is an inorganic. Like here, I will be solving inorganic chemistry questions. And I am Riturani Mandal. I am pursuing my PhD from IISc Bangalore. Recently, I am in second year of my PhD.
Okay, ma'am.
Okay, so you understood this question?
Yes, ma'am, I little bit understand, but
Okay, so you
as
can
soon as
go
possible, I
through
will.
that question, and if you have any problem, you can just write it and we can solve it in the next session. This is for all who joined late. Okay, so till now I
Okay,
have
ma'am.
solved question like from chemistry paper 2021, question number 9 and question number 13.
Okay, ma'am.
So shall we move on to the next question, or any doubt from this one? You guys know about ligand substitution, right? Also, one more thing which you should know, that mostly octahedral complexes uh, prefer having this dissociative mechanism only. For this question, I feel you guys should know that also. That is because, see, as we discussed in this one, when this reaction is taking place by associative mechanism, here the coordination number of this metal is 6, right? What is the coordination number here? Anyone?
7.
Okay. And then the product is having again coordination number of 6, right?
6.
Yeah. So we know already in an octahedral complex, it has a structure like this. So it is coordinatively saturated, right? So when it is having a coordination number of 6 only, this is coordinatively saturated complex. So it won't be preferring to go to a complex with coordination number of 7. That will make it more bulky, like more sterically crowded. Sorry, not bulky, more sterically crowded. So this metal will not prefer generally to go in a coordination number higher than 6. Another factor is that if the metal is already having full valence shell electrons. So in this case, the question which was given was COCN whole 5 Cl 3 minus. So you guys know how to find out the oxidation state for this?
Yes, ma'am.
Yeah, anyone?
-2.
No, cobalt is
Ma'am,
not.
+3.
Yeah, it's in +3. So if we consider the oxidation state of cobalt as X plus, then this cyanide
5
carries a
minus.
charge of -1. So 5 into -1. And chloride also carries a charge of -1. So 1 into -1. And the overall charge of this complex is -3, right? So X into -5 -1 is equal to -3, or X is equal to -3 plus 6. So here this cobalt is in +3 oxidation state. Okay. Can you guys count there are total how many number of electrons in this complex? Anyone?
Ma'am, you are asking for total electron count.
Yeah, total electron count for this complex. Okay, let me tell you. Okay, so there are two ways by which we can count the total number of electrons. One is neutral method, and the other one is ionic method. Are you guys familiar with this?
Yes, ma'am.
Okay, so in like it's
Ma'am, it's an 18 electron species.
yeah, okay. That's the correct answer. It's an 18 electron species. So it is both sterically and electronically saturated system in this case. Okay, for those, for everyone, I will tell how this is an 18 electron species. So someone can tell me what is like cobalt is how many electron system? Like cobalt is a D9 system.
G7?
Yeah, so it is G7 4s2, right? Okay, so it is a D9 system. We consider from neutral method of counting. Okay, so 9 electrons will come from cobalt. Each cyanide carries a like it donates 1 electron each. Okay, so 5 into 1 electron from cyanide, and Cl will also donate 1 electron. And the overall charge of this complex is -3. That means 3 electrons are added in this. So 9 plus 5 plus 1 plus 3, which is equal to 18 electron. Right? So cobalt is an 18 electron species. If you calculate this by neutral method, you have to consider like this. Ionic method is another way of calculating. In that case, first of all, you have to find out this oxidation state of metal, which we saw is 3. Okay, so from D9 system, it is now a D6 system. So 6 electrons from cobalt, from Cn will be 1. Sorry. Six. Okay. 25, 10. Chloride will be 2 plus, like everything will give 10. Just wait. So no, not true. So cyanide, when like, see, it is present as Cn minus, right? So it is a 2 electron donor. If you consider ionic method of counting, also Cl has a -1 charge, and it is also a 2 electron donor if you consider from ionic method. So in that case, what is happening is some mistake. 5 to the 10, 12. So 12 from these, right? 6 plus 5 into 2 plus 2. 6 plus 10 plus 2, which is equal to 18. So both from ionic and neutral method, you can calculate the number of electrons. But I will suggest you guys to go through neutral method, because in that case, you don't have to like find out the oxidation state of metal and all. You will just know what type of like how many d electrons are there, and finally in the final step you have to just add this charge. Like if it is 3 minus, just add 3 electrons. If it's 3 plus, just subtract 3 electrons. But in this case, in ionic method, we are already calculating the oxidation state. So this plus charge, this whatever the overall complex is having that charge, we won't be considering. Okay. So what I was trying to say is that metals which are both electronically and coordinatively saturated, they won't prefer going by associative mechanism. So in most of the cases, you will that's why find like octahedral systems going through associative mechanism. Okay. So, is it clear?
Yes, ma'am.
Yes, ma'am.
So it's already going to be 8. Anybody with any question? Because if I try the next question, we won't be able to complete that today.
Ma'am,
Yeah.
ma'am, every day we only solve the previous year's question, huh?
Yeah. So in this session, we are doing that only.
Oh, okay, ma'am.
In this whole thing, we will be solving previous year questions. And for like, if you want to go topic wise, you guys please refer to the lectures which I told you at the end of the video. Okay, that you can also find in chemistry GATE NPTEL chemistry portal. Did you
Okay.
join late, Archana?
Yes, ma'am. Actually, I joined earlier. Actually, this time my another class was there, so I jumping here and there like this.
Okay.
Sorry.
So I will show you this thing. It's fine, I understand. This is the portal. I already showed to them. So
Okay. Yeah, ma'am. I refer that. There are some lecture videos are there in topic wise.
yeah. Okay. So for
Okay.
for knowing more about the topic, please go through that, because since we are like here we are having one session, like 1 hour class per week, so it's
Okay,
not
ma'am.
possible to go through everything. But yeah, surely whatever you guys are having doubt, if you want me to say that, please tell me. I will come prepared with that, and I will let you guys know, like I will teach you guys.
Okay, ma'am.
Okay. And
Thank you, ma'am.
Okay.
yeah, and also you guys please share your feedback for this course, like what you guys are expecting, what you expect to be done in this course and all. It will be really grateful, like it will be really helpful for us, since this type of video monitoring session is starting for the first time in NPTEL courses. Okay, so we are also doing it for the first time. It will be very helpful if you guys can come up with your feedback and all. Okay.
Okay.
Ma'am, questions can be more, like 2 questions, 3 questions. I think it should be +5.
Okay, so actually, if I try to solve more questions in one video, see, it's not just questions. So first we have to say a little bit about that thing also, right? That,
Ma'am, 5 questions will be enough.
yeah,
But
that
today only 2 questions.
today it was like, today we will pick up the speed with time. Today was the first class, so 4 questions. Okay, the thing is that what I was saying is, first we are giving a brief intro about that and all. So yeah, if time permits, obviously we can take up more questions, right?
Yes, ma'am.
Okay, anything else? One is more trying to solve more questions. Uh, Anybody else?
Ma'am,
Anything?
actually, we understand your situation too. The class is too good. And what I agree with the point of Shika. What she trying to tell, she told to increase the number of questions. So before the class, you just let us know that I mean, in which your questions you're going to solve means we just refer those things. So it may easy to increase the number of questions.
Okay, you are saying that before that only I should tell you guys what are the questions we are trying to
Yeah,
discuss.
ma'am. Because it will help us to in which year you're going to discuss or something like that, so it is easy for us to prepare in the basic content.
Okay, so for this course, like for this inorganic chemistry classes, which will be on Monday 7 to 8 p.m., we will
Yes.
be like solving inorganic chemistry questions from GATE 2021.
Okay, ma'am. Thank you, ma'am.
Okay, so you guys can go and look through that question paper once. It will be like, you guys will be familiar then.
Okay,
Yeah.
thank you, ma'am.
Yeah, anything else?
No, thank you.
Okay. Okay then. Yeah, Ananda, you
Thank you
are.
very much, ma'am.
Thank you, ma'am.
Okay.
Thank
So
you, ma'am.
yeah, thanks all for joining. we will definitely try to like take your feedbacks and increase the questions, number of questions and all. Okay. Thank you. It was nice talk to you guys. Okay.
Thank you, ma'am.
Yeah.
Thank you so much.
Okay.
Okay.
Bye bye.